Hi, welcome to Day 3 Notes, where we're going to create and compare some dot plots, box plots, and histograms. Before we get into that, let's talk about a little bit about the spread and the shape of the distribution, so we know what we're talking about when we have to compare the shapes. Looking at the spread of the distribution, it refers to the variability of the data. So when we say something has less spread, the data is closer together, meaning there is less variability. This means that the data is more consistent. When looking at the data and we see that it's more spread apart, then we're talking about having more variability. That means the data is less consistent. We can also describe the shape of the distribution with a few different ways. If the data is symmetric, they have about the same shape on either side of the middle, which is the peak. However, not all symmetric data has a bell shape, but as long as the shape is approximately the same on both sides, then you can say the shape is symmetric. If a histogram is close to symmetric, then the mean and the median are also close to each other. And since the data is evenly distributed on both sides of the peak, it looks like a bell shape. Okay, let's look at the skewed right. If most of the data are on the left side, but a few larger values are on the right, where the tail is, the data are said to be skewed to the right. The few larger values bring the mean upward, but don't really affect the median, so when data are skewed right, that means the mean is larger than the median. Referring to the skewed left, if most of the data are on the right, with a few smaller values showing up on the left side of the histogram, the data are skewed to the left, where the tail is on the left. The few smaller values bring the mean down, and again, the median isn't really affected, if at all. So when the data are skewed left, the mean is smaller than the median. Looking at something that looks uniform, where it's very consistent. The data is very consistent here. The frequency of each class is very similar to that of the others, so it looks more evenly distributed. And if you have bimodals, if you have a histogram with two peaks, that means there are two values or data ranges that appear most often in the data. And this could be symmetric or non-symmetric. Okay, so I'm going to pause here and we're going to go into the notes for day 3 to create them. Okay, before we begin constructing a box and whisker plot, let's go ahead and talk about the parts of the box and whisker plot. We have the lower whisker, which is also known as the minimum. We have the upper whisker, which is also known as the maximum. Then we have quartile 1, which is the lower quartile, and quartile 3, which is the upper quartile, and then the median, which is also referred to as sometimes quartile 2. Each quartile makes up 25% of the data. So this is 25%, this is 25%, this is 25%, this is 25%. So there we have 100% of the data. The interquartile range, which is the difference between the third quartile and the first quartile, makes up 50% of the data. These 5 parts are also known as the 5-number summary, which is needed to make and construct the box plots. So let's go ahead and look at Bob's points per game. We have a list of 15 points of data, and we're going to need to find the minimum, quartile 1, median, quartile 3, and maximum in order to construct the box plot. So let's start by entering in the data for Bob's points per game. Go ahead and hit data again to clear out any previous information, and start entering Bob's points per game. You should have 15 numbers in your data list. So go ahead and finish entering that in, and I'll pause here for a moment while you enter that into your calculator. So you should have 15 points of data entered into the calculator. Go ahead and hit second data, enter for number 1, enter L1, enter 1 for the frequency, and then what you're going to look for is the 5-number summary in the calculator. So if you scroll down, so there you have the minimum, which is 3, the quartile 1, which is 8, the median is 10, the quartile 3 is 11, and the max is 15. So go ahead and enter that into your 5-number summary. Okay, great. So now we need to find out if there are any outliers. Now it looks like there are, but to be extra sure, I need to calculate the lower and upper fence. Remember from day 2 notes, there was an equation that calculated the upper and lower fence. So in order to do that first, I'm going to need to find out what the interquartile range is. Remember, the interquartile range was calculated by taking the 3rd quartile and subtracting the 1st quartile. So here we have the 3rd quartile as 11 and the 1st quartile as 8. So my interquartile range, the difference is 3. I'm going to use that to calculate my upper and lower fence. So if you remember from day 2 notes, the lower fence is calculated by taking quartile 1. Quartile 1 is 8 minus 1.5 times my interquartile range, which is 3. So 8 minus 1.5 times 3 gives me a lower fence of 3.1 or 3.5. The upper fence is calculated by taking the 3rd quartile, which is 11, plus 1.5 times my interquartile range again, times 3, and that gives me an upper fence value of 15.5. So now I'm going to look at my set of data and see, do I have any values that are lower than 3.5 or higher than 15.5? And if there are, then I have those as outliers. Well, looking at the data, I see a number here that is lower than 3.5. So I know that is one of my outliers. Now I look again to see if there are any numbers higher than 15.5, and I do not have any numbers higher than 15.5. So I don't have any other outliers above the upper fence. So I only have one outlier for Bob's points per game. Great. Now go ahead and take a moment and see if you can find Tanner's points per game 5-number summary with the lower and upper fence, and if there are any outliers. I'll pause it and go ahead and come back and check our work. Okay, check your work. Do you have the 5-number summary for Tanner's points per game, or do you need to make any adjustments or changes? If you did it correctly, you can see that there are no outliers for Tanner's points per game, and that's okay. You don't need an outlier for every set of data. Okay, now that I have the 5-number summary for both players, I'm ready to construct my box plot. So I'm going to do one for Bob, and then you're going to try it for Tanner. For Bob, okay, for the 5-number summary, I'm going to use the minimum, the quartile 1, the median, quartile 3, and the maximum. For those 5 points, I'm going to put a point above the number line that matches. So minimum is 3, quartile 1 is 8, median is 10, quartile 3 is 11, and the maximum is 15. Notice I did not put my dots on the number line. Your box plot should hover over the number line. I'm going to draw 3 vertical lines through quartile 1, median, and quartile 3, and connect those vertical lines to make my box. This is my interquartile range, and from the ends of the interquartile range, I'm going to extend my whiskers out to the minimum and maximum, and there I have my box plot. So go ahead and pause the video and see if you can construct Tanner's box plot using his 5-number summary. Okay, great. Now we're ready to compare the shapes of each boy's box plot. Okay, to compare box plots, we're going to compare them from their skewity. So if the minimum to median is longer, then we say it's skewed left. But if the median to the maximum is longer, then it's skewed right. If those distances are similar, then we say it's symmetric. So let's go ahead and look at what the distance is from the median to the maximum for Bob's. So the median to the maximum has a difference of 5. And from the minimum to the median, there's a difference of 7. So since the minimum to the median is longer, we say Bob's is skewed left. Now let's look at Tanner's. From the median to the maximum, we have a difference of 3. And from the minimum to the maximum, the minimum to the median, we have a difference of also 3. So since our differences are similar, we say Tanner has a symmetric shape. And there we have a box plot, and it's constructed, and we've compared the shapes. I'm going to stop the video here, and we will continue in video part 2 to construct a histogram and dot